In this video, we're going to talk about logarithmic functions. Logarithmic functions have applications everywhere that exponential functions have applications. In math, frequently, when we teach you how to add, we immediately teach you how to subtract. And when we teach you how to multiply, we immediately afterwards teach you how to divide. Well, if you've been watching these videos, in the previous video we talked about exponential functions, like let's say we had, for example, f of x equals 3 to the x power. So we were talking about raising different constants to a variety of exponents. Now we're going to go the other direction. So we're going to do the opposite operation of raising a constant to an exponent. Well, what that's called in mathematics is an inverse function. So here's what we're going to do for this warm-up. We're going to find the inverse function for f of x equals 3 to the x. Now, if you remember, there were 3 main steps to finding the inverse function, the second one being the most crucial. So the first step is replacing your f of x with just a y. So f of x equals 3 to the x becomes y equals 3 to the x. Now this second step is the most important step, and that's where you switch your y's and your x's. This is the most crucial step. This is technically the inverse function, x equals 3 to the y. The only problem with it is we haven't isolated the y yet. So the final step was we were going to isolate y. Now, we have a problem isolating y from x equals 3 to the y. There's no way with, I don't know, a root, like a y root we could take of both sides to get those y's to cancel out. That's not going to work. So x equals 3 to the y. Right now, we don't have a way of isolating that y up in the exponent. Now, the 2 mathematicians that we can credit with coming up with this were Napier first, John Napier first, and then Leonhard Euler. And they used the notation y equals log base 3 of x to mean the same thing as x equals 3 to the y. So the inverse function for 3 to the x power we write as log base 3 of x. A word on notation and how you're writing this. The 3 that you're writing down here is what we call the base, and this number is written smaller than the rest of them. It's small like a footnote if you were writing an essay. But the letters in the word log and x, these are all the same sign. So if you're taking your notes, if taking notes on this, there is sort of a line here. Whoops. A line here. Where the letters log and x are all on the same line, and that 3 is smaller. The base 3 is smaller. Okay, so using that information, let's just practice converting back and forth between this form, the logarithm form, and this form, the exponential form. Okay, so we have our 2 forms written here in a generic way. We have y equals log base b of x. So this is the logarithmic form, or log form for short. And x equals b to the y is the exponential form, or exponent form. And these 2 things mean exactly the same thing. One just has the y isolated and one has the x isolated. So for the first few, let's simply convert Let's start with exponent form, and we'll convert these to log form. Okay, so let's do something pretty straightforward like 5 squared equals 25. Not even any variables in there, just something that's true. Now watch what happens when we convert this into the log form. So here we have this in exponent form, so it's like this. X equals b to the y. Ooh, it's written kind of backwards though, right? Because the exponential is on the left side over here, but on the right side over here. Nonetheless, watch how I convert this. When I'm converting from exponent form to log form, there are a couple of things that I want to line up. First is the base. Notice that the base underneath the exponent, b, is the same as the base underneath the log. So for our problem, the base underneath the exponent is this 5. So we must have log base 5. Let me highlight that. Okay, so the base underneath the log is the same as the base underneath the exponent. The second thing I want you to notice is that the inside of the log is what the exponential is equal to. So this 5 squared is equal to 25. That must be what goes right here. So this would be 5 log base 5 of 25. And then the last thing that I want to bring your attention to is probably one of the most important. The exponent on the exponent of y on our base is what the log is equal to. So the exponent here is 2, so the log must be equal to 2. So 5 to the 2 equals 25 is the same as log base 5 of 25 equals 2. Okay, so that is how we translate that into log form. I want to take a second before we do another one, and I want to write this in English so that we don't lose sight of what we're doing. The first and most important thing I want to point out is that the log, what the log is equal to up here, we've highlighted it in green, the log itself is equal to the exponent. So logs are really just exponents. That's all they are. Notice the log here is equal to 2. We have log base 5 of 25 is 2, and 2 is the exponent. So when we see the word log here, a log is really just a fancy word for the word exponent. So when I translate this into English, this is what I have. The log base 5 in English means the exponent put on 5 to make 25. So the exponent we put on a 5 to make 25. Oh, that exponent is or equals 2. Is 2. So this is read, the exponent we put on 5 to make it a 25 is 2. Okay, let's try another one where we're just converting. Let's do something that's true. So let's do 4 to the negative 3 equals 1 over 64. And we just want to convert it into log form. Okay. So now here's what I do. When I convert these into log form, I always start at the same spot. Since the bases are always equal to each other, the base under the exponent is always the same as the base under the log, I start there. So I have log base 4 of 1 over 64 equals the exponent, negative 3. Starting at the base, log base 4 of, going to the other side, 1 over 64 equals negative 3. Log base 4 of 1 over 64 equals the exponent, equals negative 3. Look back over here. Log base 5 of 25 equals 2. Log base 5 of 25 equals 2. And if I were to write this one in English, it would be, let's see, let me erase down here. Whoops. So if I were to fill in these blanks here, this one would be the log, or the exponent, we put on a 4. The exponent put on 4 to make 1 over 64 is negative 3. The exponent we put on a 4 to make 1 over 64 is negative 3. Oh, right, because negative means 1 over. Okay, let's try a few more of these. Here would be the conversion. All right, the next one, let's convert to log form. Something true. Let's do 5 equals 25 to the 1/2 power. Okay, that better be true. Just to double check real quickly. Remember, a 1/2 exponent means a square root. So this really means 5 equals the square root of 25. Oh, yep, it's true. Okay, cool. Just wanted to make sure I was putting something on here that was valid. So that wasn't the point of the problem. The point of the problem was to convert it. So let's convert the true statement, 5 is equal to 25 to the 1/2 power, into log form. Now, again, I always start at the base. So the base in this case is 25. So I'm going to have log base 25, and then I go around the equal sign of 5 is or equals 1/2. So I start at the base and I go around. Log base 25, because the number under the base under the exponent is the same as the base under the log. So log base 25 of 5 equals 1/2. Okay, so in English, that's our answer. But in English, what that means is the log, or the exponent, that we put on 25 to make 5 is 1/2. So in English, this means the log, or the exponent, we put on a 25 to make it a 5 is 1/2. Okay, let's do just a couple more. Let's do, for number 4, let's do 117 to the 0 equals 1. Yep, okay, good. That's a true statement. Anything to the 0 power is 1. So as I'm converting, again, I'm going to start at the base. So the base under the exponent is the same as the base under the log. So log base 117, and then I go around the equal sign, of 1 equals the exponent, equals 0. Of 1 equals 0. Okay, so there's one more time. The base under the exponent is the same as the base under the log. So log base 117 of 1 is equal to 0. Or in regular English, let's erase these, the exponent, or the log, that we put on 117 to make it a 1 is the exponent 0? Well, yeah, anything to the 0 power is going to make it a 1, so that's true. The exponent, or the log, we put on 117 to make it a 1 is 0. Okay, let's do a couple more. All right, the next one I want to do 10 to the 3 is equal to 1,000. Cool, true statement. And the other one I want to do, I'm going to write it up here at the same time. I want to do e to the x equals 12. Because there's two things I want you to know. First of all, we have two bases that appear a bunch in mathematics. Imagine it's pretty easy to see that base 10 would appear a lot. Our whole decimal system is based off of tens. So a base 10 would appear really, really frequently, as would the base e. That's a very, very common log to show up. So I'm going to show you how we write these when we convert them. Remember, when I'm converting, I always start at the base because the base under the exponent matches the base under the log. So log base 10 and then of 1,000 equals the exponent. The log is always equal to the exponent. So in English, I won't write this all out, but this is the exponent. You put on a 10 to turn it into a 1,000 is 3. And that would be how we would convert. Now, log base 10, since a base 10 is such an extraordinarily common or frequent logarithm, we actually call this the common log. So we would write log of 1,000 equals 3 without the base written in there. So if no base is written in, then it's supposed to be a base 10. Just kind of like the square root of 4 means the second root of 4, and we don't write the 2 in. If no base is written in, it's supposed to be a base 10. So we wouldn't write log base 10 of 1,000. We would simply write log of 1,000. And I erased way too much of that. There we go. Okay. The other base that we have shorthand for is base E. Now remember, when we're rewriting this, we're going to start at the base. So at first, when I'm doing my work, I am going to just write log base E. So it's log base E of 12 equals the exponent, in this case, x. Okay, so this would normally be okay for our answer, but there is a shorthand for this one too. Log base E occurs really, really frequently. We call this the natural log, and we write ln of ln of 12 equals x, and what that means is log base E of 12 equals x. So if you see ln, it means the natural log or log base E. So let me recap those two very frequent logs. So we have two really frequently used logarithms, log base 10 of, let's say, a, and log base e of a. And what we write instead of log base 10 of a is log a. So again, if you see the word log but you don't see a base, it means base 10. What we write instead of log base e of a is ln of a. The top one, log base 10, is called the common log. And the one below it, log base e, is called the natural log. And one quick note on notation, I tend to write, when I write lna, my L is a very scripty A. A lot of my online students ask me where in comes from, the IN. So I tend to not write my logarithms like that. When I'm writing the natural log, I write a scripty L, so I can tell it's an L and not an I. Okay, Let's do some problems where we go back the other way from log form into exponent form. All right, first one I want to do when we convert to exponent form, let's do log base 2 of 1/16 equals -4. Okay, so I'm coming up with a true statement, and I just need to convert it into exponent form. In the same way I was doing before, where I start at the base, I'm going to do that again here. So remember, the base under the log is the same as the base under the exponent. And remember that the log itself is equal to the exponent. So if the log is equal to -4, -4 must be the exponent on that 2. So again, we're kind of starting at the base and going around the equals sign. 2 to the -4 exponent equals 1/16. Cool. So again, notice when we were translating the previous ones, the exponent we put on a 2 to make it 1/16 is an exponent -4. Yep, sure enough, 2 to the -4. Remember, negative means 1 over for the exponents. So 2 to the -4 is 1 over 2 to the 4th, or 1/16. Let's do another one. Let's do something that's true. Let's do log base 6 of 36 equals 2. Okay, and I'm just converting it into its exponent form. Well, you can probably see this one taking shape. The base under the log is the same as the base under the exponent. What the log is equal to is the exponent, 6 to the 2, and 6 to the 2 is, of course, equal to 36. So there is our exponent form. Okay, let's do a couple of those really frequent logs. Let's do log of 0.1 equals -1. And then for comparison's sake, let's do ln of x equals 8. Okay, so I want to get us used to these two very frequent logs that won't have the bases written in, and I want you to know it doesn't have to have all numbers in them. We can have variables in these. So the difference between number 3 and number 4 primarily is what the base is. And I am a very visual person. I need to see that base. So if it says log, like in number 3, without the base written, I'm going to write 10. Because log, the word log without the base is log base 10. In number 4, though, on the other hand, if it says ln without the base written, it's an e, log base e. Okay, so to do number 3, starting at the base, ooh, glad I wrote the 10 in there, because that's my starting point. So 10 to the -1 exponent is equal to 0.1. And that is that in exponent form. And sure enough, 10 to the -1 is 1/10. So 1/10 is equal to 1/10 in decimal form. Just double checking, making sure it's a true statement. Number 4, again, start at the base. Glad I have it written in there so I can see the base. Base is e. What the log is equal to is the exponent, so e to the 8th, and then it equals the inside, equals x. So e to the 8th equals x. Is that an exponent form? The last thing I want to do is several problems where we evaluate logarithms without the use of calculators. And that's really because most calculators only have log base 10 and log base e buttons on them. So maybe log and an ln button. They don't have the ability to, let's say, do what is log base 2 of 8. So figuring out log base 2 of 8 without a calculator is actually really easy to do in a lot of cases, and the calculator wouldn't help us anyway. So remember, if we're evaluating without a calculator, what you need to remember is this. This is really asking what is the log means what is the exponent. So what is the exponent we put on a 2 to turn it into an 8. For this first example, I'm going to write that. What is the exponent put on a 2 to make it 8? That's the question. Well, 2 to the 3 power equals 8, so the exponent is our logarithm. The exponent is our answer. So log base 2 of 8 is 3 because 2 to the 3 exponent is 8. Okay, let's do another one. Let's do log base 7 of 1 over 49. Now I'm going to put those parentheses in there just for the sake of showing what's on the inside, but you can put parentheses around the inside of the log or not in these problems. So again, this is asking what is the log or what is the exponent that we put on a 7 to make it 1 over 49. Okay, well obviously 7 to the 2 makes it 49, and a negative would make it a fraction, 1 over 49. So whatever the exponent is our answer. Okay, let's do a couple more. Once you get the hang of these, you should be able to do them pretty quickly. So let's do log base 3 of 9. So I'm not going to write out what I did before in red. What is the log or what is the exponent we put on a 3 to turn it into a 9? Well, 3 to the 2 power is equal to 9. What if we did log base 738 of 1? What is the exponent we put on 738 to get out a 1? 738 to what exponent equals 1? Ooh, 0. Any number raised to the 0 will give you a 1. So for number 5, if I asked what is log base b of 1, and I didn't even have the decency to tell you what b is, you could tell me this is 0 because the exponent I put on any number to turn it into a 1 is the exponent 0. What if we did log base 3 of 1/9? What is the exponent we put on a 3 to make it 1 over 9? Well, 3 to the 2 would make it a 9. So 3 to the negative 2 would make it 1/9. And one last one. Let's do what is log of 100? Okay, well, it doesn't have the base written in, but it has the word log, so it must be base 10. So what is the exponent I'm going to put on a 10 to make it a 100? Ooh, 10 to the 2 is equal to 100. Now, I like this last one. This last one you can check on your calculator. If you have the log button on your calculator, you probably also, for a shift or a second key, have a 10 to the X button right next to it. You should be able to try and check with your calculator that log of 100 gives you a 2.